Hi everyone, welcome to this tutorial on dimensionality reduction and visualization with t-SNE and R. My name is Shafali Chaudhary and today I'll show you how to use the t-SNE algorithm to reduce the dimensionality of your data and visualize it in a lower dimensional space. So let's get started. First, what is t-SNE? t-SNE or T-distributed stochastic neighbor embedding is a nonlinear dimensionality reduction technique that is particularly well suited for embedding high dimensional data into a low dimensional space for visualization. First, let's set up the necessary packages. We will use the RTSNE package for t-SNE and ggplot2 for visualization. Now let's load the packages by writing these libraries. After that, we'll use the iris dataset for this tutorial. Before we proceed with dimensionality reduction, let's explore the dataset to understand its structure and characteristics. The iris dataset contains measurements of sepal length, sepal width, and petal width for three different species of iris flowers. In this step, we explore the dataset by displaying first few rows, calculating summary statistics, and then creating a pair plot to visualize relationships between variables. Before we run the t-SNE algorithm, we need to prepare the data. We will start by removing the labels, scaling the features, and removing any duplicate rows. Scaling ensures that all features contribute equally to the distance calculations. Now, let's run the t-SNE algorithm on the prepared data. We will use the RTSNE function to perform the dimensionality reduction. The RTSNE function reduces the dimensionality of the data to two dimensions, which we can then visualize. The perplexity controls the balance between local and global aspects of the data, and max underscore iter specifies the number of iterations. To get the best results from t-SNE, it's important to tune the parameters. The perplexity parameter is particularly important as it affects the number of nearest neighbors that are considered when computing the pairwise similarities. Let's experiment with, different values of perplexity to see how they affect the visualization. We have taken perplexity values as 10 and 20. And then we have plotted the graph for both of them. So in this, we ran t-SNE with different perplexity values and visualized the results to see how the parameter affects the clustering. As you can see, different perplexity values can lead to different visualizations. So it's important to experiment with this parameter. So now to understand the advantages of t-SNE, let's compare it with PCA, which is basically principal component analysis. PCA is a linear dimensionality reduction technique that transforms the data into a new coordinate system such that the greatest variances by any projection of the data come to lie on the first coordinates. We'll run PCA on the same dataset and visualize the results. So in this step, we ran PCA on the data set and visualized the results to compare with t-SNE. PCA is a linear technique and may not capture the complex structures in the data, as well as t-SNE, which is non-linear and often better at preserving local structures. So that's it for this tutorial on dimensionality reduction and visualization with t-SNE in R. We have covered how to set up t-SNE, prepare the data, run the t-SNE algorithm, tune parameters, and compare t-SNE with PCA. I hope you found this tutorial helpful and that you'll use t-SNE for your own dimensionality reduction and visualization projects. Thanks for watching.